Hello everyone. Welcome to this video on the test for Cyclicity problem. Let's look at the problem description first. We are given a singly linked list. We need to see if there is a cycle within this list or not. If there is a cycle, return the node at the start of the cycle. If no cycle exists, we return null. For example, in the given linked list, we need to return 5, as this is the start of the cycle. Let's see the problem's signature. The list node class is defined on the right. The input is the head of a singly linked list of the list node class. The output is the start node of the cycle. And the corner case is if the head is null, we return null. Right off the bat, we can think of several ways to solve this problem. Here is primitive idea number 1. We could explore nodes starting from the head and store all visited nodes in a hash table. If we visit a node already in the hash table, a cycle exists. If the search ends at the tail, no cycle exists. The time complexity of this problem is big O of n, since we traverse the linked list only once. The space complexity is also big O of n, since we are using a hash table here. Since it must store all the values in the list, it is space consuming. Let's try another primitive idea without using additional storage. We could traverse the list in 2 loops. The outer loop traverses the nodes one by one. The inner loop starts from the head and traverses as many nodes as the outer loop has gone so far. If the node being visited by the outer loop is visited twice, a cycle has been detected. If the outer loop reaches the end of the list, there is no cycle. In our example here, the red pointer is the outer loop, and the yellow pointer is the inner loop. When the red pointer reaches 5, the yellow pointer will reach 5 more than once. This lets us know that there is a cycle. The time complexity of this is big O of n squared, since we are using 2 loops here. The space complexity is big O of 1, since we just use 2 variables. Are there any optimizations? Could we find a solution to spend linear time in constant space while solving this problem? Well, we could use 2 pointers, a fast one and a slow one, to traverse the list. In each iteration, the slow pointer advances by 1, while the fast pointer advances by 2. If the 2 pointers meet, the list has a cycle. If the fast pointer jumps the slow one, the slow pointer will equal the fast pointer in the next iteration. In our example, we can see the red pointer is the fast one and the yellow pointer is the slow one. They both start from head and meet at 8. After we know there is a cycle, we could find the start node by calculating the cycle length c. Because we know if there is a node in the cycle, it is easy to find the cycle length. Here, we just move the red pointer step by step, memorizing steps, until it meets the yellow pointer again. We get the cycle length is 4 here. Then, we use 2 more pointers starting from the head. These are the green and blue pointers. Green advances the length of the cycle first. After that, green and blue go together one by one. They will meet at the start node of the cycle, which in this case is 5.
If you found this video helpful, BitTiger Pro has a comprehensive series of videos covering all the skills you need for the coding interview. We explain the latest technical interview problems used by top companies like Google, Facebook, and Microsoft. Subscribe to BitTiger Pro and get access today.
Let's see the code example. We have the fast and slow pointers here. First, we advance fast by 2 and slow by 1 to find if there is a cycle. If a cycle exists, we calculate the cycle length by moving fast pointer. Next, we use two more pointers called first and second. We move first pointer by cycle length steps. Then, we move first and second pointers together until they meet. Finally, we return second as it is the start node of the cycle. If there is no cycle, we return null. The time complexity is big O of n, since we linearly traverse the linked list. The space complexity is big O of 1, since we use only 4 variables here. Could we find the start node without calculating the cycle length c? Well, after fast and slow meet, we could do some calculations to solve this. Let's assume that x is the number of nodes from head to the start of the cycle, and y is the number of nodes from the start of the cycle to the meeting point. So, when they meet, fast minus slow must equal the cycle length. This is shown by solving the following equation. 2 times x plus y minus x plus y equals to c. Simplifying this, we get x equals c minus y. We could set slow equal to head and move slow and fast together one step each time. They will meet at the start node of cycle, which in this case is 5. Here is the code example. When slow and fast meet, there is a cycle. We simply set slow equal to head and move the pointers together until slow equals fast. When they meet, slow is the start of the cycle. If there is no cycle, we return null. The time complexity is big O of n, since we linearly traverse the linked list. The space complexity is a constant big O of 1, since we use only 2 variables here. Thank you for joining us.